Hi, this is Mr. Manley, and I'm going to look at a challenging problem with inverse here. First of all, this is a little difficult to read. I'll just rewrite it out here. So this is f of x is equal to x plus 7 squared. So first of all, if you look down here, again, this is hard to read also. Here we're being asked for f negative 1 of x is equal to. And then there's this additional piece here for the domain. For the domain. And then we're going to respond with some domain. All right, so what's happening in this problem? It starts off clearly enough. If you've worked with the algebraic inverse, which you should have up to this point, what's happening with the algebraic inverse is I'm going to substitute a y for the name of the function. I'm going to switch x and y. And then I'm going to solve for y. All right, so look at solving for y here. This brings up a little bit of algebraic review here and work with radicals. So when I take the square root of both sides, do you recall what to do? If I'm solving and I take the square root of both sides, I'm going to go plus or minus over here. So I'm going to have plus or minus square root of x is equal to, and then here hopefully you see that the square root of the square undoes itself, and I just have y plus 7 on the right side. Okay, continue solving for y, and I get negative 7 plus or minus rad x is equal to y. And then I want to say I've got the inverse, right? I say the inverse f negative 1 of x is equal to negative 7 plus or minus rad x. But the problem here is that I'm saying that this is the inverse function, but this is not a function. If I were to look at this graphically, it would look something like this. So that would be the plus part, and this would be the negative part. And then hopefully you remember that, oh, that's not a function because it doesn't pass the vertical line test. So what's happening here can be seen back at the beginning. And you might have missed this, but this says that f is equal to x plus 7 squared, which is what I wrote here. But then I didn't say this part here. It's equal to x plus 7 squared for the domain negative 7 to infinity. So that's for the domain negative 7 to infinity. So let's look at that graphically. I did a little graph of x plus 7 squared. Now, if you're looking at this video, I would presume you've done transformations. So you should be able to graph this really quickly. This is the transformation of the x squared parabola, and it's the transformation 7 units to the left. Okay, so I'm going to give myself I think I'll give myself a scale of, 2 might not even be enough for our purposes here, but I'll make it work. So I'm going to give myself, I'm going to call that negative 2. So if I transform this 7 to the left, I'm going to be 2, 4, 6, 7. There's the vertex. And then this parabola goes up here, like that, and up here, like that. So that's x plus 7 squared, but the function says f of x equals x plus 7 squared for the domain, and then for the domain, that's part of the function also. So for the domain, and that's saying negative 7, again, that's a little bit difficult to read, but it's saying -7 to infinity. So -7 to infinity, those are the x values for which we are taking this function. So all of these values over here, I don't want, because they're less than -7. Those are x values less than -7. So the actual graph of this looks like just the right half. So I'm going to take away the left half, and that's it. So that's the actual function, f of x equals x plus 7 squared, for values of x from -7 to infinity. All right. Now, when I get down here on the inverse, down here, remember I said what this looks like is, it looks like this. There's a part up there and a part down there. Well, let's be more specific. Again, we could, if I broke this up into two pieces, I'd have -7 plus rad x. Okay, so what's that? That's rad x moved 7 to the right. So that would be like that. And then this other one is going to be not 7 to the right. Hopefully you caught me on that. 7 down. So this here is going to be rad x plus a -7, and the -7 moves it down. So I'm going to go down. Yeah, I'll use the same scale. So I'll use a scale of 2, 2, 4, 6, 7. All right, so that's the rad x function, 7 moves 7 down. And then this other one, this other piece of it, -7 minus rad x. So do you see how I broke this up into its two pieces? So it's plus or minus. So I said here is the plus piece, which is what I just graphed there. And then here is the minus piece. Now what would that minus piece be? It would be a reflection through the x-axis and then 7 down. So that would be this. All right, now remember when you learned about these inverse functions, when you learned about inverse, we said it's the reflection through the line y equals x. So there's the line y equals x. Now which of these pieces, if this is my function f, which of these pieces is the reflection through this line? Would you say it's this piece is the mirror image? Or would you say that this piece is the mirror image? So, I mean, I hope you understand what I'm saying by mirror image, and I hope that you have the visual acuity to see this, but, I mean, to me, certainly, it's obvious that this piece is the mirror image of the piece that I'm given. So I want to eliminate this piece here. I don't want that. And I'm going to eliminate that piece of the function here, down here. I don't want that piece, because that's where this piece came from. So now I'm down to -7 plus rad x. That's the inverse. -7 plus rad x. And then what's the domain of that? For the domain, what's the domain of -7 plus rad x? I mean, you can look at the picture and see, right? What values of x are possible for that function? Are there any, do I have x as -1 over here? No, the function's not over there. The function starts here at x is 0 and then continues to the right infinitely. So the domain is 0 to infinity. All right, so that's one of the more challenging application here. And we would like to get up to the challenging application, and I think definitely it's doable. And then the more depth of understanding you can get, hopefully through this video, or thinking about it as you do it, as you follow the steps, the better. But I do think that this is something that every pre-calculus student can do, and then hopefully also understand.